One of the worst feelings in the world is the sense of helplessness, knowing you can't change something. That's exactly how many people felt when news broke about an asteroid on a potential collision course with Earth. In just a few days, Asteroid 2024, YR4, went from being unknown to making headlines worldwide. By the time this video was made, it reached a peak of 3.1% chance of hitting Earth. But before you panic, let's have a serious conversation about asteroids and why the discovery of 2024 YR4 might actually be one of the best pieces of news in history. Asteroids are small, rocky bodies orbiting the Sun, just like Earth. When I say small, I'm comparing them to planets. But asteroids come in all sizes. The one that wiped out the dinosaurs was 10 kilometers in diameter. And at any given moment, there are countless asteroids in our cosmic neighborhood. What you're seeing on screen? Those are just the ones we know about. Many of them collide with Earth every year, but most are too small to cause significant damage. Here's where it's important to explain the difference between asteroids, meteors, and meteorites, because they're not the same thing. An asteroid is a rock orbiting the Sun. A meteorite is a small piece of an asteroid that broke off due to some impact. These terms refer to the objects while they're in space. Meteors are the rocks that enter Earth's atmosphere, and the term meteor refers to the streak of light and smoke they leave behind. In other words, a meteor is the visual effect of an object burning through our atmosphere, while an asteroid is what the object actually is. Now back to what matters. Most asteroids aren't a threat to humans, but some are. The main category of dangerous asteroids is near-Earth objects, or NEOS. Currently, there are over 37,000 of these cataloged in orbits relatively close to our planet. If an asteroid or comet hits Earth, it'll likely be one of these. Depending on the size, the impact could cause damage. Asteroids over 20 meters in diameter usually have enough energy to cause harm if they explode near the ground. A 50-meter asteroid is believed to have caused the Tunguska event, leveling 80 million trees in a remote part of Russia, an area larger than Sao Paulo. But even the Tunguska asteroid wasn't big enough to reach the ground. It disintegrated in the atmosphere. Only excessively large asteroids, usually over 100 meters, tend to survive our atmosphere. An asteroid of that size could level a major city with the energy of the largest bomb ever detonated by humanity, the Tsar Bomba. Impacts from asteroids over 1 kilometer can cause regional or even global effects like tsunamis, earthquakes, or climate change. The damage from something that size would be catastrophic, but not enough to wipe out humanity. For that, we'd need an asteroid like the one that killed the dinosaurs, 10 kilometers in size. Asteroids that big are an existential threat. But here's the good news. Over the past few decades, numerous projects have cataloged thousands of near-Earth asteroids. The bigger the asteroid, the easier it is to spot. This is reassuring because we likely already know about most asteroids that could pose an existential risk. And none of them are heading our way. Thanks, Bruce Willis. In fact, the number of new asteroids being identified is decreasing each year, indicating we found most of the dangerous ones. Enter the newest addition to the list, 2024 YR4. On January 29, 2025, the International Asteroid Warning Network issued an impact alert for 2032. Initially, 2024 YR4 had a 1.3% chance of hitting Earth. The same odds as flipping a coin and getting heads 6 times in a row. Unlikely, but not impossible. With a size between 40 and 90 meters, 2024 YR4 was quickly classified as a level 3 on the Torino scale, which measures the danger of an asteroid based on its impact probability and potential damage. Level 3 is the lowest level that requires attention, starting with monitoring to better determine its trajectory. Shortly after discovery, the impact probability rose to over 3%, a record high. To put that in perspective, 3% is the same as flipping a coin and getting heads 5 times in a row. But since then, the probability has dropped to 1.5%, then 0.2%. If you're wondering why the odds fluctuated so much, it's because of how asteroid orbits are calculated. When we think of orbits, we imagine thin lines around the Sun. But this ignores the uncertainty in an asteroid's movement. What we actually know is a range of possible future positions based on limited measurements. If we plot the possible positions of 2024 YR4, it looks like a wide band rather than a thin line. This band represents all possible orbits given our current data. The reason this asteroid deserves attention is that on December 22nd, 2032, Earth will be within this band. More precisely, Earth's path that day crosses just over 0.2% of the asteroid's possible locations. So there's a chance Earth and the asteroid could be in the same place at the same time. A dramatic way of saying collision. In other words, Earth isn't directly in the asteroid's path, but within the margin of error for its possible trajectories. This explains why the impact probability rose and then fell. Initially, the chance was just over 1%, meaning Earth's path overlapped with 1% of the asteroid's possible paths. As we gathered more data, the band narrowed, and Earth remained within it, causing the probability to rise to 3%. This is expected. As we refine our measurements, the impact probability tends to rise until Earth exits the band, causing the probability to plummet to 0. That's exactly what happened with 2024 YR4. But one day, this won't be the case. One day, the probability will rise, 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 and it'll become clear that an asteroid will hit Earth. Maybe not today, maybe not in 2032, but someday it will happen. When that day comes, what can we do? The first step in dealing with a potential asteroid impact is determining if it will hit Earth. Seems obvious, right? Using 2024 YR4 as an example, when will we know for sure? The answer: it depends. Ideally, an observatory might have accidentally detected this asteroid during its last close approach in 2020. If so, we might get a clear answer this year. Otherwise, we'll have to wait until its next close approach in 2028 to observe it properly. That observation will determine if a collision is imminent. Suppose 2025 ends inconclusively, and 2024 YR4 remains high on the Torino scale. In that case, we'll need to start planning for potential impacts. The first important factor is that even if the asteroid hits Earth, it doesn't necessarily mean significant damage. Only 3% of Earth's surface is inhabited by humans, and only a small fraction of that is densely populated. We already have an idea of where the asteroid might land. Its orbit crosses Earth near the equator, spanning northern South America, the Pacific, Central Africa, India, and southern Asia. The most likely scenario is an ocean or uninhabited land impact, where we'd just collect data. The second most likely scenario is a low population impact, where we'd have 4 years to evacuate and minimize loss of life. The worst-case scenario, less than 1 in 150,000 odds, is the asteroid hitting a major city like Lagos or Mumbai. Evacuating millions would be a logistical nightmare. If this seems likely by 2028, our only option would be to deflect the asteroid. And here's more good news. We've already done this once with the DART mission in 2021. In that test, a spacecraft collided with the asteroid Dimorphos, altering its orbit by 32 minutes, far more than expected. This success was due not only to the impact, but also the dust ejected afterward, which amplified the effect. This shows that crashing spacecraft into asteroids is a viable strategy for deflection. It could even work for 2024 YR4 if needed. But we might not need to be so drastic, especially since we'd have years to prepare. In 2028, 2024 YR4 will approach Earth again, giving us a chance to interact with it. In the worst case, we'd only need to alter its orbit by less than 15 minutes per year, just 3 seconds per day. An impact could achieve this, but there might be gentler methods like changing its albedo, how much sunlight it reflects. By painting the asteroid, we could gradually shift its orbit. Between painting, crashing, or evacuating, what's the best option? It depends on where the impact would occur and the asteroid's composition. We don't know yet for 2024 YR4, But if another high-risk asteroid is identified early, these options will still be available. The key to avoiding an asteroid impact is early detection, which is why the discovery of 2024 YR4 is such good news. Thanks to the DART mission, we know we can deflect asteroids. The real danger was finding a threat too late. With 2024 YR4, we have plenty of time to act. So, don't lose sleep over this asteroid. The chance of impact is low, and even if it does hit, we have options. For the first time in a while, this video might actually help you sleep better at night. Thanks for watching, and see you next time.